All right, Andre, take it away.
All right, thank you, Jesse. I hope you can see my screen right now. I will have to handle any technical issues this afternoon. I got an issue with my headset. Hope it's not going to happen. I changed my setting. I hope it's going to work. So go meet Lua. I know that Jesse changed the title here, and I followed his recommendation. I thought, well, Meetup, go. Again, I'm Andre, working with Jesse, SBS, and during the day, I'm a manager, and at night, I change my hat and have fun coding. So Go is one of my favorite languages, and many others because I can do whatever I want. I do that for fun, so I jump from one to another. And one thing I like to do is to mix languages. And last time when we met, I mentioned about a book, and I'm going to try to show this book here. Black Hat Go that I could certainly recommend now. Initially, when I looked at it, I said, well, from a security standpoint, maybe not as deep as I wanted. But there was one chapter on uh, Go plugins. And of course, he touches on the Go plugins that we have now available since 1.8, I think. Uh, but mostly there was a part that I was the most interested was the ability to use Lua within Go. So I said, that's an interesting topic, mixing languages. So hence the choice of that topic for today. In the past, I did that in different situations for fun or for real, meaning real for work, between languages like Java, JNI, and C. For those doing C and have done Java, it's a pain, but it was somehow fun for the challenges. Python and C, of course, is more classic. But even things like using languages like Pinshell and Jython on top of the JVM, but using them not as their own languages, but as a way to extend or to customize the main host language. So, this being said, why would you be interested to use Lua with Go or Go with Lua? Because it goes both ways. Well, it happens that Lua is actually one of those favorite languages to extend tools or different frameworks. And I put a list here, and this is just barely scratching the surface. There are so many others, but some of those I'm sure you know about. And Nginx, for example, has the ability to kind of be customized with Lua. There's even a version called Open Rusty where you can do a full website, just not more than a website actually, but a very, very sophisticated way of using Lua. Wireshark allows customization with Lua, Nmap as well. Pandoc as if you know I'm sure you know Pandoc, kind of a document format conversion, so many ways of doing those things, like for example, converting Markdown to PDF or to HTML and many others. It has a mechanism where you can use Lua as a filter so that you can customize the generation of the document. HA Proxy, Redis for Roblox, it's a game online for kids. Rockbox is more of a hardware for running on a small music like Sansa MP3 player, those kind of, you can put them on many of those small devices. Site is a Scintilla editor. It's a very a small editor that I use and can be customized with Lua. And I discovered yesterday talking to my son, there is this language called Love. I don't know how to pronounce it, but I call it Love. And it's actually a 2D game engine that is based on Lua. And currently there's a class, I believe a CS class offered for free, one of those MOOC online by Harvard, where they use this language to do teaching on programming. So I thought, hey, maybe why not Lua and Go. That was kind of the start. So now there is a little bit, that's going to hurt right at the beginning because mixing the classic Lua and Go means to have to go through Seago. And for anyone who has used Seago, and I bet some of you may have done that, it's a bit of a pain. I will show you some of those things. So still using CGO, how we can embed Lua in Go, that's another aspect I want to show. And then extend Lua with Go. And in particular, in that case, I'm going to use a special implementation of the Lua language called luajit. It has a just-in-time compiler, and it has a library, FFI library, that makes things a little bit easier. That's not included by default in the standard Lua implementation. And then we'll end up on easier notes, especially with the Lua interpreter written in Go. There are many of them. I was very surprised to discover so many of them, and I picked one to show what you can do. And that was certainly the easiest things to do comparing to the other things I had to go through. CGO. I tried to find the right emoji to describe what I felt when I did it. The CGO aspect of it, and we're just a few groups, a few number of people. It's going to be easy to ask questions, but does anyone among the people here tonight has done some CGO work with Go? Or I'm sure some of you may have done like C with something else, right? So when you deal with C, it's actually quite nice to combine with something else. Python and C works well because all those languages have their background is C. So you can do C and Python, C and Lua, for example. You can do, there are new languages that are supporting that pretty well, like Zig, for those who may know, TCL, all those kind of Perl, everything is kind of has a way to kind of combine with C. Well, with Go is a bit different because Go doesn't necessarily understand C. So that there are a few aspects that can be a bit annoying. So first example, and we're going to see code. I hope it's not a problem. I'm sure it's better than just seeing the slides, right? The first example is very simple. And again, right now we're not on, using Lua. It's just C and Go. Therefore, CGO. Simple example, inline code, the C code is inline, and I try to represent that graphically. It's Go code, and we have the C code in Go comments. So how does it look? Well, it looks something like this. Very simple example, a full example here. We're going to see, we're going to run as well. Very simple. By the way, all the examples I'm going to show are very short, maximum probably 20 lines. And this one is, well, hello world kind of things. You see the first part here. I hope you can see my, I'm not sure you can see my mouse. Can you see my mouse when I hover it or not?
Yes.
Yes. So the first part here, you can see the comments here. That's the C code. And pretty straightforward. You do the proper include for the IO, and you have a simple method, hello, and a printf. Nothing special. And you have to import the C package. Important things, this is where it starts to be kind of a bit awkward already. If you don't have the import touching the comment here, it's not going to work. And I struggle with that. So that's the reason I put a note here. Now, when you know it, after it's okay. And then when in the main, we just call the C package. And on the C package, we call the method hello. So let's see how it looks and how it works. If I can make that working. So this is the example, nothing different what we saw before. And here we have the main file here, and I already compiled it, but I'm going to recompile it just in case. Nothing special in the compilation, just compiling it with this code, and now we can run it. And again, at this point, we have not seen something that is surprising, except for anyone who has never used CGO will say, oh, what is that thing? Next. All right, so you saw the C code was within the Go code. Now we're going to take that out, and we're going to create a program, a simple C program, the same as before, and we will ensure that Go can also deal with it. I have the same file, the main Go. This time the header files are in a Go comment. So it's not the full code, it's just including the header files that are the H, only one. We have the hello H. And we will see those two files here. We're going to compile them and create a library. And as part of the header file, in this one, you will see there is no instruction on linking. I was actually surprised. Normally, this should be there, and we'll see after in a more complex example where it is there. It simply works. I was able to remove it, and it still works. So I don't know. I really have. There may be a quick things here that I missed, but I would have expected that it would need that, but he was able to find it and do it properly. So let's look at this. The code looks like this. Remember the comments before. This time we just have the includes, and we need also to include the standard lib here. We import C. A little bit of something new here. We have to import unsafe. So unsafe, the name means unsafe. So you know when you import it that it's unsafe, right? Dylan mentioned earlier about the memory, those kind of things. That starts to be kind of a little bit murky. And here's the way we use it. So we're going to call the first one, we call the method like before. And we're going to call another one. This time we want to pass a parameter to that method in the C code. In order to do that, we have to call a special method so that the string that we are so used to do in Go, that are very simple, that are managed by Go, in that case, it's gonna be possible. So we need to use the CString method on C in order to have a pointer to an array of character. And because it's not managed anymore, we say it wasn't safe. We want to be sure we won't forget to fray that particular zone in memory. So we call that, and at least here the nicety about it is that Go has this notion of defer. So of course, in this case, it's just a main. That would not be a prime per se, but if it was another function that we would guarantee that when it goes out of the function, then the free call will be submitted, and we'll have the memory of this pointer to be freed up. And we call the method print name. We're going to see this code here. All right. So that was the inline we saw earlier. Now we have a library. Let me close that here. You still see my screen? Yep. Okay. So you see the code, right? Because I don't see anymore the sign around my Jesse. I don't see anymore the green rectangle. So I want to be sure. It's good. All right. So we can see here the hello method and the print method, nothing else, just to do, I should use the term function here, it would be more appropriate. The first one has no parameters. The second one has an argument pointer to an array of character here. And we just call the normal C method printf from the standard IO library. And at this point, it's very simple. We also want to have a header file that will provide the signature to those two functions. So we don't have to declare that in the header of the Go file. The Go file will be able to find this on the Go compiler more precisely. Our Go code, we already saw it, nothing special. And let's look at the make file at least to see what's happening for the compilation. So we have two steps really. One is to create a library from the C code. And the second one, simply, we just built our Go file. All right, so here, our file here, my default make entry is to build. We just compiled the C code with GCC. By the way, I'm using a Windows subsystem for Linux. I'm on Windows right now, but it would be easier to present that. Then we link to generate a static library here. And at the end, we're going to compile. Everything is compiled. And I generate all my files here for this tonight as GoLua so that it's cleaner after that when I want to do something, especially when I want to clean up everything. All right. And seems to work. It's happy. By the way, this code is already available on GitHub. So if you wanted to look at it, except I didn't give you where to find it, but if you want it before the end of this discussion, let me know and I can certainly point you to it. It's part of the slides, by the way, too. All right, so now we have seen two examples, one inline and the second one using some separate header file and C file. What else do we have? Well, let's look at it from a different angle. Do you remember the title was Go meet Lua and vice versa? So we saw the Go meet C, and now we're going to see the C meet Go somehow. It's going to prepare the ground for our Lua part. That seems to be a little bit more convoluted here. It is not too much. The difference, though, is that now what we want to do is from Go to generate something that C can consume. Right. So one way to do that is to use, again, we're going to have this in comments. I'm always a little bit kind of confused when you use comment for doing something. Think about, I don't know, flow in JavaScript, dialyzer in Elixir or Erlang, or you use the comments to do something until you forget those are comments and you forget to maintain that, and then it doesn't work anymore. So anyway, we have a main Go file. We will see how it is and how this file is. And we will have to use like a particular build mode that is one of the build mode for the Go compilation that to generate two files, a golib.h and a golib.so. That's our dynamic library here. That header file will be included in the main file that is a main.c. This one is C code. And that to generate, I use the default value of the generated executable here. And then when we execute this a.out file, it will, of course, load dynamically the library that was generated before. The code looks like this. I took a very simple example I've reused over time so that, in the other example with you so that we don't have to see something too different. Very simple. Go has a lot of libraries that are available and tooling in the OS, for example, package. And this one is just to get the current directory. So you may have seen that get working directory. So we have a particular function that we call pwd here, like when you do print working directory. It takes, of course, particular things here because it has to be understood by C. So we cannot use the normal string. So we're going to use a pointer to this array of character here. Of course, we had to import our C. We're still in C Go mode. The rest of the code, everything that is in a kind of a black color here will be what you're used to. And each time we have a call to the C package, of course, we may have to expect something a little bit special here. Notice that the function main is empty. It has to be done this way. I should have put a comment here. Without it, it's not going to compile because Go expects to have a main. So if you don't have a main, say, oh, what's going on with me here? Because this whole notion of CGO almost feels like an addendum to Go, really. It may not be true, by the way. You can feel free to chime in if it's not true, but it definitely feels like a bit awkward to some degree. All right, so let's look at the code. This was a lib here. Now again, you have an export. I'm going to show you the main .c file, and maybe we can go to the golib.h as well. Let me close that. All right, so the main, nothing really special, except that now we have this golib.h. This one is generated, this golib.h is generated through the compilation with the special build mode for a shared library. We don't have to create that. It's created by the compiler. Because you have this export, it knows what to export and will provide all the information necessary for in this header file. The main is this very classic one, nothing really special. Here we print one of the function existing in C. Now this one is a bit particular because now we can invoke that pwd function that we define in our Go code. Because we saw the Go code, I don't want to go back to it necessarily, but let's see how it's being compiled. This time, we have this particular build here that's going to build a dynamic library, and we have to provide information about the build mode. And the name is pretty expressive here, C shared, meaning we're going to share with C. And of course, we want to compile this particular file. And then after the second step, now we use GCC with our the main file, and of course provide information about the library itself. This library will be not part of the compilation, also part of the execution. So you will need to have both files together in order to work like any dynamic library. You can forget about that. I provided this as a way to kind of get smaller executable, but it's not the main problem for tonight. Let's look at how it works. All right, I'm going to generate that again. We see the compilation we talked about. We generate our dynamic library, then we compile a C code, and now we have a.out here has been generated, and we can call it. And we see this one, if you remember, this one was printed directly in the C code with the usual print. This was a puts actually. And this one is also, it's a printf, so the C code, but the content of the current directory here is coming from the Go code. Any questions so far?
I have one question.
Yes.
Is static compilation available for Go? I saw that there was a build mode for shared library, which is what you showed.
So yes, we're going to see that's something a little bit more detailed. I'm only going to have Lua. So later I'm going to take Lua. I'm going to use the same concept we saw with Seago. We take the regular Lua library and do a static static executable that will include all the libraries, and you don't need to carry anything else. Yeah, so that's a yes. Now, what is weird is that, and it may work different ways, but in that case, you have to provide the library, the linking parameters inside Go as extra like comments in the what I would call the Seago comments, if it makes sense. And we will see those. So, very good question.
Okay, thank you.
So now we start to approach the main theme for tonight that was about Lua and Go. So far, we have not touched on that yet. Lua in Go. All right, first exercise I thought would have been very easy actually. Ended up a little bit more tricky than I thought. The idea is that I have a simple Go executable. Right, we have this here, and I want to use the libraries and header file that are coming from Lua as the language, and see if I could use the functions that are exposed by this library actually in order to execute my Go code. So far, it seems to be kind of reasonable as a thought process. What it does, so here this one will take on this. If you remember when we had the example of C code that was the header file pointed to the C code, that's the same thing. But here, instead of me generating that particular, those headers, I'm just taking the old language. It's actually it's very small language and not that many files, but take all the header file, take the static library that was generated for the library of Lua and make it available. We'll see the headers to answer Jesse's question. And at the end, I have an executable that is a Go executable, statically compiled in this case, and read the hello Lua and spit out whatever this hello Lua is telling me. Just one way, just like having this being executed. I'm going to show you the code, but just as a reminder, this is Seago again, and the emoji here came up perfectly well. And I had major issues with, so Seago doesn't support macros, C macros. So what it means is that if you have libraries, like in the case of Lua's, where the C code includes a lot of those kind of niceties, let's say, or sugar code that helps kind of making it a little bit easier to invoke the functions. And those are not supported. So what I needed to do is that each time I had one of those functions, I had to look at what that function was translating into, and in order to call the final function, the real one. Of course, unsafe pointers, we have to remember about saving the freeing up this code. So let's look at the code itself. All right, so done with Seago. Now we are on the Seago Lua, and the idea is to execute a Lua file. Lua has this function called do file that is supposed to just execute a Lua file. The Go code looks like this. So now we start to have way more of those. And to Jesse's points earlier, we can provide the LD flags here as a particular kind of a instruction, like you would have in a pragma instruction in C++, and or C, or even Lim has this as well. And you tell Go, hey, by the way, you will have to link with this library. That's the local library. And in that case, I needed also the mat library, and I need the dynamic library. And this here, of course, you need the header file. This is the header file, a few of the standard C library, and the mat header file, and all the rest here. We're talking about Lua itself. Of course, we still have to import our C package, and the unsafe here, that should be a kind of a red flag already. The rest is not anything special. I mean, we just have like a few lines of code, but they're annoying to get there. Now we start to get into a little bit what Lua requires when you embed Lua somewhere in any language, but in C or in Go for that matter, is that we need to create the Lua state, and the Lua state is going to be used to interface with anything you do in Lua. It has a stack that you have to deal with, but everything is managed through this Lua state. When you have created this Lua state, then after you can pass it to any Lua function that need to be invoked. Like here in this case, we want to have access to the standard library. Then we open the standard library and we pass that particular Lua state. And I'm going to skip at the end. At the end, we want to be sure we close that particular Lua state. Again, main function would not be a problem per se. Most probably, at least the program will be done anyway. But if you had this in a function somewhere, that would be a problem. And we face again the same problem as before. Here we have a CC string. Therefore, it's not safe. I want to be sure I defer the freeing up of that particular pointer. Now I can call the function to load that file into that Lua state. And finally, I can call that chunk of code using this Lua p call k that was not the one documented, but it was the one that I ended up finding after kind of following the trace of the different defined functions that were called. So certainly not very fun, not very easy to read. I put here for the sake of it the normal one that we call is the Lua do file. Very simple. Simple. I shouldn't never say that simple. It's never simple. Lua state and fn is read the name of the file. When you have a C-based type of code, this is all what you need to do. But in that case, a bit different because we need to call this one that really happens to be another define, and then ultimately the one we need to call that the real function. Right? That's this one here. And same thing for the p call. Normally it's just a p call, but in that case I need to follow the trace. For today there was only one level, so I could pick this one, and this is the one we see here. So not really fun and pleasant, and for playing with it, that's great. For real work, I'm not sure. Anyway, this was the path. Next one. All right. I thought, man, I like coding with having a REPL available to me. That's the reason I like things like, Python, or I like Elixir, Erlang, Tcl. They all have a REPL. It's kind of convenient. Hey, now even Java has one. You can play with it. You can get immediate feedback. It's kind of cool. Say, okay, I'm going to write a Lua REPL in Go. So really what it does is, you have a loop, and each time you have an instruction coming to your as a standard in, then you send that to the interpreter that happens to be Lua and try to get back a result and present the result to the user. Well, that was kind of an extension of what we did earlier. This time you can see, so same idea. We have all the header files, the single link, Seago linking that we talked about, and we generate an executable that will be able to kind of potentially interpret some basic instructions. The loop itself is managed through Go, so that part is fine. The interpretation of the code itself is through Lua, and it's kind of a bit of a, let's say, pain. All right, Go again. Problem with C macro, we talked about it, unsafe and kind of a pain to debug. Let's look at it anyway. All right, that's the repo. The header file, I'm not going to go through, those are pretty big one, but we want to see the main file, the main Go file, where we have, like before, all the includes. We have our environment variable for linking, and then the rest is really for Go, except when we see this one, something is wrong again. Not wrong per se, but we know we have to be careful. This is just for fun, that doesn't matter. And we have our REPL. The REPL itself is just mostly Go, so not a problem until we reach that point, and we start very quickly feeling that we are back in the mud here, C string and calling the method on the C package, freeing the pointer. This one is particularly interesting because this one, no way to differ. We're in a loop here, right? That's the loop of the REPL. So if I do differ here, it's not going to work until we're done with actually the old function. So we want to be sure we free up right away, at least right away, as long as we don't need anymore that particular pointer here, because we load the pointer. That is this expression here. We load it in the Lua state. So we can free that original pointer. It's already in the Lua state, so we're kind of covered. And then we call that particular instruction. We can have an error here. When there is an error, I don't bother. I clear the stack of the Lua state, and I come back to because it was getting a bit too much. Then we get the result. Potentially, we fetch the result back from the Lua state. And of course, we're talking about a pointer to an array of characters here, so I need to handle that properly. And then I will have to free up that pointer. And finally, we can print that on the screen in our REPL. Notice that here we have a Go string. So we got the two here. The first one is that that's a C string. It means we convert a regular Go string into something that C can understand. Whereas here we did the opposite. So we get something that is a typical C string, if I can use the term, and we convert it to something that Go can understand. And when we're done, like before, we close the Lua state. Let's see how this works. Compilation will be very similar as before, so there is no surprise there. We just compile, everything is provided as a instruction in the Go comment. All right, so we're going to do Go Lua as the last one on the Go part. We should be, well, almost. All right, and because I'm lazy here, I'm just going to run this one. One thing I do different here by doing that, you may have seen that on the make file, is that if you just run a REPL like this, it's not going to handle properly the read line. So if you type something, you cannot manipulate the current line you're typing on. You cannot call back. But if you, in that case, it's wrapped with RL wrap that maybe some of you know about, and that allows to get that without having to include that in your code itself. Let's take a few examples to see if it works. Again, I'm kind of lazy here, and I don't want you to have to bear with me typing. So, okay, that's very simple. And here, so Lua, like more languages now, support that concept of immediately invocable function execution, like this one, for example. And we can look at other things that Lua has, some kind of simple things we can find in different libraries. And I'm going to stop after that, except I will probably show you this one. That's an interesting thing that Lua has. We won't see it really, but it's happened behind the scene. If you work with Lua, you can see that a lot. So Lua has concept of table and meta table that really allows you to do anything you want. You can use Lua as an object-oriented language if you want, using that concept, and it's kind of powerful. You can create modules and everything. All right. This was for fun. I did that here, and of course I can exit. I use the same kind of concept as the Node.js repo. Any questions?
Maybe just one comment. That one spot. First of all, I notice how valuable it is to have the ability to defer when you're dealing with needing to do in a free of an unsafe pointer. I think in that code example, there is the possibility to use like an anonymous block to be able to use a defer still. If it makes you feel better. I guess it's 6 of one, half a dozen of the other in the end, but.
Okay, so yeah, I'm interested to know more about it. So right now, are you referring to those that were inside the loop or the one before? Because here I don't have any differ, because I could not have the differ. Yeah,
so with each of those places where you're doing the defer, you could wrap it in a block.
Okay, let me go back. This one.
Not that you need to do it now or anything, but
no, it's just to be sure I get. I'm here to learn too. So if there is anything, so here this one has a differ here. So where would be the? Are you I have only one, so I would assume that if there was indeed a few of them, I could have a block with them.
Yeah. So if you go back to the other file that you were looking at. Yeah, there you go. So you could wrap lines 68 through 71 in an anonymous block and use a defer. It would be the same, but it would maybe feel a little bit better, the fact that you're using defer. I don't know.
I see. No, that's a good point. That's really a good point. So yeah. So you could have like from above this guy here.
Yeah, or actually, if I'm reading it correctly, you could open an anonymous block on line 68.
Yeah.
And you could likely close it on.
Yeah, after this one here.
After line 82.
Yes.
And and then use the defer keywords and get the benefit of knowing that it would happen. It just wouldn't necessarily have to happen right there.
No, that's a very good point, actually. Yeah, and it would happen here at the end when you get out of that block. Well, good point. I would have not thought about that. So thank you for bringing this up. Yeah, very good point. Thank you, Jesse. All right, are we going to get out of this Seagull tanks? Maybe. All right, going to go to another domain here. Let's try to extend Lua with Go. And it's going to be a repeat of some of the things we have done, but in a different context. So I want to use luajit now. We used Lua so far. Lua has different interpreters. One of them is called luajit, very fast implementation of Lua that includes very complex and sophisticated just-in-time interpreter. A bit behind regarding the implementation of the spec of Lua, but very, very fast. If you can look at it, you can see it's quite impressive what mostly one person did that. The nice thing about it is that it has, by default, included in standard library, the ability to implement or declare C code, and to execute that C code. Now we know also that Go can be seen as C code. I've done that a few times already tonight. And by exporting a function, we can create a dynamic library using the C shared like before. And as soon as it's in this state, when it goes to 2, whatever is going to run this code, execute this particular code, will have no notion it's coming from Go. You just see that as if it was a C library. And we'll use to avoid going to doing things that are so different from one another. I use the same concept as before. It's a current working directory. It happens Lua doesn't have by default current directory method, working directory method. So why not? Maybe have it for free now. All right. So here I detail that a bit more. It has an FFI library. We see that. It could be interesting to extend Lua to include functions not available in the standard library of Lua. For example, Lua doesn't have like a basic HTTP client. Well, it happens that Go is pretty good for that. It has everything for that. Or it doesn't have, like I said, like some of those basic, maybe not that basic, but standard encoding. And we see an example with encoding later. It's very easy in Go to even have like a cryptographic library, so you could expand for you exactly what you would like for your Lua implementation without having to the complexity of C and different libraries in C, and they are all kind of compiled differently. That was actually a possibility here, a little bit more appealing than what we saw before. So what we want to do, I want to call this getWD function, get working directory, export it in Go, and then use the FFI module in luajit in order to call it. And yeah, just a small thing, we have to add a C declaration here, not a big deal, and then we can call that particular function. So let's see how it works. All right, guess what? The Go code is the same as what we had before, the same as the C example, but we want to see how it looks in Lua. All right, luajit here. So the C code, we saw it already. Let's look at a very simple implementation. Let me close that. All right. A few languages have this concept of loading a dynamic library dynamically. Yeah, you can do that easily in Python, for example. NewLISP has this concept as well, and luajit has it. So you just have to invoke, load that particular module, the FFI module. Then now you can load that dynamic library. And as long as you declare the particular signature for those functions, you can call them. In that case, we'll have again to call it here. We just call it, this is the golib here. We call that function we built in Go. And there is just, again, a slight kind of a difference because the string seen from Lua versus the C string is a bit different, but it's already implemented in the FFI module. And then in the end, we just print that. This old function here is a Lua function that wrap this old things to make it a bit easier to kind of manage. So you have seen all the code. I'm just going to execute it, and really it's already probably built. I'm going to build it again. Build mode C shared. And in theory, so I'm going to have to use luajit now. I'm going to use luajit because Lua doesn't have this function. I can call get CWD. And that is it. Current working directory that's the current working directory. I didn't hard code that, just in case you wonder. It's here. And I went one step further just to show you, and I'm going to show you that in the code, but it's more on the Lua side. So you can certainly create a Go a module that is a Lua module that will wrap all this kind of a little bit messier code and make it available on that particular function. For anyone doing JavaScript, that kind of may kind of remind a little bit of that way of doing modules. And then now, if I want to use it, I can certainly use it easily. I can just require this module and call the function pwd on it, and it's going to return the same result. All right, that was a way to expand my luajit with Go. This one fell a bit more at home. I think there is certainly kind of a possibility here. Now, using a Lua interpreter in Go. So we shift. Forget about CGO. So far, it has been used almost everywhere. What we have here, and I found a few implementation of it, and one of them was actually described in the book I showed you earlier, is to use the Lua interpreter that is implemented in Go. And in that case, I use this particular one, Gopher Lua, and I'm going to use this. The methods are the same signature. I think whoever implemented it really followed what Lua does. So it's almost like you can look at the specs of Lua and kind of, even though it's implemented in Go, you can use those, but you have all the benefits of Go. You don't get out of Go. It's really only in Go. And I'm going to show you 3 examples. For the sake of time, are you still doing okay, Jesse, on time? Yeah. Yeah. Okay. You say yes.
Sorry,
All right. So,
to get to my unmute. Yes,
sorry.
we're
Yes.
doing fine on time. Thank you.
All right. So, 2 easy one. Do string is really to execute a string that contains kind of a statement or an expression in Lua. Second one is to execute a file, and we saw that we already did that earlier, but we can see better now how it looks. And finally, something I mentioned of base64. Again, base64 not included in Lua. Go has it. Maybe I can get the benefit of that. And in particular, we see an example where we do both in the same context. So what we do is that we're going to expose functions that are in Go to the Lua interpreter that is in Go as well. And we're going to call Go to ask Go to execute a Lua program. Now we get very close to what those different programs that I talked about at the beginning, Nginx and all the others, to do something that could be valuable. Much more simple. Everything is in Go. You know, the little gopher is happy. You can see that. And then we just have to import in the same way we do with Go usually. The Go code is going to execute and extend the Lua code. And really talking about the last of those examples, I can show you the code for all of them. All right, there's the Go Lua here. I'm going to show you the do string, then we'll go to the base64. The do string is really showing how simple now it becomes. Just importing that particular package. If you remember, we still have the Lua state, not a problem. We do a defer here, but in that case, we still do the close because it's a bit the way Lua works, but it's just more Go specific. That's it. Nothing that you would that has to do with the fact that it's written in C, just because the way the implementation was done. And then we can call the doString directly. DoString is also a Go function in this case, and we execute this particular string, and nothing really special otherwise. It feels Go much more than the others before. All right, so let's go to Go Lua. There's do string, and no, not make. It's just a regular Go Lua build, and I should have a Go Lua. Hello, GolangMN. And it's not hard coded. Let's do the, so I should have stayed there. Let's look at the base64. It's going to be just really the same concept, but a little bit more elaborated. And in particular, we can see how we can expose functions to the Lua interpreter. All right, here's this one. All right, so the idea is to expose a function that will be called base64. Oh, sorry. The function will be on code, but on top of something that will be called in Lua, it's called a meta table. Remember the table I told you about? The meta tables are there here to kind of almost mimic like some object that's happening in Lua. And then the module base64 could be invoked with the encode function. So that's one thing. And also, we'll do the do file. It means we're going to execute that particular file that is an interaction. And I'm going to show you that as well. All right, that's the Lua file. Here, that's pure Lua code. It says, kind of an input, trying to get input from a user at the command line. Same thing here, we read something from the command line. And then now we add something that is specific, because now we're going to use that particular thing that we made available to the engine, the Lua engine, the Go Lua engine, called the encode on the particular string that we got from the input, the standard in. And then finally, we just print it. And everything is going to be done through Go, meaning Go is going to execute that because it has the Go interpreter, the Lua interpreter in Go embedded inside the code itself. And it has done a registration of a particular meta table with a function that will allow you to code that code that is the base64 code of Go for Lua. Go back here. We can see in the main, we have the usual suspects. We create a state and we defer the close. We're clean here. Now we have added a registration. Our registration is this one. Creating a meta table of base64. We set it to global, so it's going to be available globally within the Lua state. And we have a field on that particular kind of meta table, if you will, or more exactly that namespace inside the meta table that is called encode, and that points to that function. That is this base64 encode function that is implemented here. Right? So because it's still kind of Lua-ish, we still have to respect things. If you can see here, we don't pass a string here. Sorry, this one doesn't have any information about what we're going to pass. We always pass that Lua state. And the Lua, and within the Lua state, we're going to fetch what we want. Now, in that case, we want to have a string that's going to pass in the Lua, be passed in the Lua state. We're going to apply the encoding. That's the regular base64 encoding of Go, and we have imported it, and it takes an array of bytes here. We get the result, and we finally end up pushing back on the stack the result of that what came as a result, and we convert that to a Lua string, a string that Lua will be able to understand. The last, what we return is the number of results that are returned in the stack. If you return 3 results, it's going to look in the stack for the 3 results. Kind of almost the same way on this side. If you know that you take 3 parameters, maybe one is a string, another one is an integer, something like that, you will have to know them and take them as they come. This is the only piece that is a bit kind of a bit more kind of a non-standard. It's really driven by Lua itself and the Lua specs. And let's look at this. Be sure it's still working. Right. All right, so I'm going to enter something here, GolangMN. And here's the base64 encoded value of GolangMN. Again, all those examples are intentionally scoped to something that is easy to digest. I think we can go way further than that, but for the purpose tonight, that was, I think, sufficient. I wanted to add a note about Go plugging, just for information. Didn't play with it really. Maybe some of you have done it. We talked about build mode earlier with the C shared. There is a new build mode, I believe, that exists since Go 1.8. It's called a plugin. What it does, and I didn't use it, so bear with me here. My understanding, it allows for creating modular Go programs. So you can create different modular and libraries. Go libraries can be reused by other Go program. And, it can be a plugin type of things if you want it. I don't know too much about it. That's my understanding. It's probably worth exploring. Now that we have seen that, I think there are plenty of ideas that could be used for that. Configuration files can be interesting, where you can have configuration files that could be with information or data that is dynamic, that is not just a pure like a static stuff, where you can depend on some logic that can be implemented in Go, but could be read properly by sorry, a configuration file that would have logic built in Lua, and that Go would be able to read. Now, I'm still thinking that all the CGO stuff is kind of a bit messy. The Lua implementation is the one I'm thinking about on those ideas. You can expose internal APIs to customers that can, so that you don't have to build them something custom for each time. Extension, like it has been done in games on in C or C++ with Lua. I think in that case, that's possible with Go. Any kind of templating languages, HTML, XML. I know it's kind of maybe not anymore what people are doing. Whatever next ML or JSON Markdown, where you can provide ways to generate something or add logic. I think the filtering text processing, like Pandoc is doing with the filters in Lua, would certainly be possible as well. And any other ideas, you can probably add your own. All right, what did we do? We look at the CGO, heard a bit doing it. We saw a few ways of embedding Lua in Go, extended luajit with Go, and particularly in that case, using the FFI module from luajit. And then embedding and extending Lua with the Lua interpreter written in Go. This one was certainly the most pleasant of all the others that I had to go through, and maybe give a couple of ideas that could be explored. I put a bunch of resources here. I don't think it's necessarily needed to go through. Everything will be available on GitHub. The code is already there, and actually you can see here on this particular slide, the first line here, if I knew I would do that. That first line is the code, and the current code is there. I don't think I made any modification. Feel free to, everything is published under an MIT license. I may have forgotten to put the MIT file, but I think I put it somewhere, at least in the README, that's MIT. And this document itself is also will also be part of in the repo somewhere. I don't remember if I put a particular license, but I'll be careful to be sure that it's either Creative Commons share alike, something like that, easy to use. I can go quickly to the others. You can see some resources I provided. There are a few interpreters, Lua interpreters in Go. A few Go books that are interesting. The Black Hat Go, I already mentioned about it. Lua has a lot of resources. If you noticed, I didn't want to do anything about Lua itself tonight. The goal was not to show how Lua works. I think any of you, you're doing many languages, will have no problem to pick up Lua. So it was more about how we can take another language and mix that in Go. And the Lua books, my favorite is this one is, if you can, that's from of course it shows up, it's the original written by the author of Lua. This one I talked about, this simple language for learning how to code and take advantage of Lua. And I don't want to forget the attribution. This afternoon I had a talk on licenses and copyright, so I tried to be careful with this. All the pictures that I have here are all referred to with the proper attributions. And this one is released under the Creative Commons Share Alike 4.0. And this is about it. If you have any questions, very happy to try to answer, or to take them to try to answer them later if I cannot answer tonight.
This was great, Andre. Thank you so much. Any
You're
questions before we stop the recording? I'll just say I've had some experience with Lua and embedding Lua and binding to it from Python and Ada programming language. And so yeah, this is really interesting to see how this works with Golang. Really well done. Thank you, Andre.
You're welcome.
Any questions before we stop the recording? Otherwise, I'll go ahead and stop the recording, and then if there's any questions beyond that.
Yeah, so I kind of have a question. So, Andre, you mentioned about a little bit on one hand, like creating wrapper functions in Lua, and I know in like Python, if you're like creating interface between like something like C and Python, there's like a system called like Swig for creating wrapper interfaces and stuff. So I'm kind of wondering, like, between like embedding like Lua and Golang, like, what do you kind of think like is the necessity field for like, or the complexity to create like wrapper interfaces, and is there any like code generators you know, or do you think that the process is simple enough to be able to like just do like a C include file and C go const, something like that?
Yeah, so the wrapper I talked about earlier, I think I did that in 2 environments. So the one I used is the one in Lua itself. I tend to, when you have a massive amount of code, maybe those Swig stuff, for example, might be a bit easier because at some point in time it becomes unbearable. But it feels, from what I had to do in the past, and maybe Jesse the same, usually those things are, I feel that it's more applicable to something small enough. And indeed, in those cases, I would rather use the bare bone tools that are available rather than adding another level of complexity with the wrapper. And the reason being is that it's already hard to debug like this. But if you have a wrapper, now you have another level of debugging that comes into place. You mentioned about Python. So with Python, you can do something similar to what I did here with the luajit, where you can use C-type, for example, or the CFFI, that I think is a library also in Python. And you use the dynamic language library. And even those feel much more, most probably will fill the need of what you have. And if you go to the next step where you really create a C extension to Python, that already you kind of go one step further, right? Like that start to be kind of tougher. Then after the next step is indeed those wrappers like Swig, and I've always stayed away from them, so I cannot speak too much about them. But yeah, I like to kind of keep the complexity as low as possible. And if I can avoid to do that and I can do everything in Go, I would rather to do everything in Go. Keep in mind that's kind of this idea of exploring stuff more necessarily than finding a real application. Although I think that we have seen Lua being used a lot in some of those situations where instead of writing my own interpreter to expose some APIs to my customers, then maybe Lua could be a good fit. I hope I answered your question. I don't know, I went on a tangent, but.
Yeah, I think you answered pretty well.
Any other questions? All right, I'll go ahead and stop the recording. Thanks again, Andre.
You're welcome. Just time for another beer. It's not recorded, right?
I'm hitting the stop record button.
Oh man, gosh, you can cut this part.
I don't know why it's not working.
Oh, I shut my mouth. I don't say anything until it's.
I don't know.
Oh. Do I need to stop the sharing maybe?
Oh, here we go. I found it.
Oh.